Welcome to Pomodoro Joe for Saturday, July 1st, 2023. Today we're doing LeetCode problem 2305, fair distribution of cookies. This is a medium problem. All right, so in this one, we are essentially given a list of bags of cookies. So each one of the bags in this cookies list contains a certain number of cookies, and that will be the value at this list index. We are also given the number k, kids. So this is how many kids we need to distribute these bags of cookies to. Now our goal is to distribute the bags of cookies as evenly as possible. Now we're not allowed to open the bags and take the cookies out and rearrange them or redistribute them. We have to give the bags as a whole, so we can't change the number of cookies per bag. Okay, and so this problem states the unfairness of a distribution is defined as the maximum total cookies obtained by a single child in the distribution. Return the minimum unfairness of all distributions. So essentially, all the kids are going to get some cookies. We have to use up all the bags of cookies, and at the end, one kid might have more cookies than all the other kids. That will be the maximum value or the unfairness of this distribution. We're trying to minimize the unfairness. All right, let's put 25 minutes on the Pomodoro timer and get started. So for this, I think I will use a recursive solution. So let's start with some result. Let's see, we'll start it at, well, we should probably start at infinite to start with, and we'll return the result at the end. So we're looking for the minimum value. So we start high and we can reduce it till we find the minimum unfairness. All right, let's have an internal recursive function here. So we'll call this distribute cookies recurse. All right, so what do we take for this one? I think I'll just start out taking the index of the bag of cookies that we're on. So my approach to this will be, it's something called backtracking. Essentially, we'll just go through every bag of cookies. We'll give that bag of cookies to one of the kids. Then we'll check to see what's the best distribution for the remaining bag of cookies. Then we'll take that bag of cookies back from the kid, give it to the next kid, check the recursive solution for the best distribution from that point. Essentially, you're trying all these different combinations by giving bags of cookies to kids, then going back and taking one of those bags back, redistributing it to a different kid, then taking another bag back, redistributing it to another kid, so on and so forth. Now it sounds complicated, but it's actually not that hard. This is something you do quite often when you're looking for different permutations of things. For example, you have a bunch of letters, you want to see what are the different permutations. You'll try putting the first letter in the first slot and then find the permutations for the remaining letters in the remaining slots. Then you'll pop that letter out of the first slot and you'll try the second letter in the first slot and do the same permutation recurse on the remaining letters with the remaining slots. Then you'll pop the second letter out, put the third letter in, etc. So you sort of put something in, try the different permutations, take that thing out, and try a different thing. We're just doing the same thing here, but with cookies. So I'll have a cookie index here. Okay, so if our cookie index is out of bounds, that'll be our base case. So let's check our base case here. Let's see, I'm not keeping track of my number of cookies. So let's do that here. All right, so the cookie count, this is actually the bags of cookie count, but that's too long of a name, so I'll call it cookie count. So that's the length of our cookies. So if our cookie index is equal to our cookie count, that means it's one more than the max index. Well, at that point, we can just return. What do we return? Well, at this point, we'll return the maximum number of cookies stored in each of our kids, or I shouldn't say stored in each of our kids. At this point, we return the maximum number of cookies each kid would have. So we also need to keep track of the number of cookies each kid has. We can keep track of it by passing it through, or because we're backtracking, we'll just keep track of it out here as sort of a global, and we can update it as we go. So we'll call this kids cookies. And initially, each kid has 0 cookies, and that's k kids. All right, so if we get to the last index, then we just return the max of our kids' cookies. Again, this is just storing the number of cookies that kid has. So kid at index 0 has 0 cookies, kid at index 1 has 0 cookies, so on and so forth. All right, so that takes care of our base case. Now we need to keep track of our recursive case. So what's the recursive case? Well, we'll have another result. This is an internal result. Maybe I should call this something else. That's all right. This internal result, again, we'll start this one at infinite. We will return our result at the end. Now for this is where we go through and give our bag of cookies to every one of the kids and then recurse on the remaining cookies and see how we do. All right, so for every kid, or maybe I'll call it kid index in range K. All right, so for every kid, we're going to give this bag of cookies to that kid. So that's just going to be the kid's cookie count. All right, so the kid at this kid index will get the cookies at this cookie index. Awesome. Now I'm going to put the backtracking part next, just so I don't forget to do this. So after we do our recurse, we're going to want to take these cookies back from this kid. All right, so this is our basic backtracking. We're going to give this kid at kid index the cookies at cookie index. Then we'll do our recursive call. That'll be in this gap here. And then after we do our recursive call, we'll grab that kid and demand our cookies back. So we're going to take these cookies at cookie index back from that kid. This is just to try all the different permutations. Give it to a kid, do the recurse, then take it back. Give it to the next kid, do the recurse, take it back. Keep going. All right, so in here, this is our part where we do our recurse. So this is our recurse option. So at this point, we need to do a recursive call. Let's grab this here. We're going to pass in the next bag of cookies. So that's cookie index plus 1. Then we see, is this option better than our current result? So our result will equal the max. Oh, no, it's the min. We want the min. The min of our result, or this option. All right, so now we've checked to see if we have a better result than our current result, and then we demand the cookies back from the kid. So this should do it. All right, now out here, we do need to make our initial call to our recursive function. So this result will just be the recursive cookies, blah, blah, blah. And we'll pass in 0 as our initial index for our cookies. Okay, so this is pretty straightforward, right? We have our base case, we've gone through all the bags of cookies, and we'll just grab the maximum bag from all the kids, or the maximum total from all the kids. That'll be our return value. Otherwise, we'll go through, we'll try giving this bag of cookies to every one of the kids, just to see which one gives us the best answer. We'll try all our recursive options, figure out which one's the best answer, then we'll take that bag of cookies back from the kid. All right, let's see if this works. That seems to work. All right, let's see if we can pass all the tests. Oh, we have a time limit exceeded. And look, this is not a lot of entries, so we do pretty well. We only have a couple test cases we're not passing, but we basically don't pass with very few entries. So let's see if we can just speed this up a little bit. All right, we'll use that test case. So what can we do to speed this up? There are a couple things that we can do. The first thing that comes to mind is we need to give every kid some cookies. We can't leave some kid out. So if there are ever kids that don't have cookies, that's not a valid distribution. So in here, we're doing a bunch of extra work looking at permutations where some kids don't have any cookies. So for example, let's say, actually let's go back to our list here. So here, we might give the first kid every single bag of cookies and then try to redistribute this last bag among the remaining 7 kids. That's never going to be a valid distribution. There aren't enough bags of cookies left for the kids that don't have cookies. So let's keep track of the number of kids that don't have cookies. So I'll have kids with no cookies here. So we're going to keep track of how many kids there are that don't have any cookies. And that can be another one of these base cases. So let's see, remaining bags. Well, how many bags are left? Well, that's going to be our cookie count minus our cookie index. Actually, this could be -1 even, I think. Wait, the cookie count, let's say there's 1 bag, minus our cookie index could be 1. Oh, but then we'd be at this point. So yeah, I think it is just cookie count minus cookie index. All right, so if the cookie count minus the cookie index, if that is less than, let's call this remaining bags. So if the remaining bags is less than the kids with no cookies, well then we're done. We can't do this one, so we have to return infinite at this point. All right. So now we're checking to see if we have enough bags for the remaining kids with no cookies. But that does mean we need to update our 2 recursive calls here. So this guy needs to update kids with no cookies. I'm gonna have to call this new kids with no cookies. All right, so at this point we need to check, are we giving a kid that didn't have any cookies some bag of cookies? That's basically how we know this kid has cookies. So at this point, we'll grab this kid. All right. So if the kid that we're giving cookies to, I'll have to do this check before I add the cookies, is equal to 0. Let's grab this. Yep, I have to do that before I get to this point. So if this kid doesn't have any cookies, and we're just about to give this kid some cookies, we can reduce our kids with no cookies by 1. All right, so I actually need to keep my new kids with no cookies out here. That's going to be equal to the kids with no cookies. New kids with no cookies minus equals 1, because we're giving this kid who had no cookies some cookies. All right. And that should be it, because once we're out here, we're just basically throwing this away. We only need it for the recursive call. We don't need to restore it out here, because we're going to be creating it fresh each time from this input. All right. But we do need to start our initial call with some kids with no cookies, and all the kids have no cookies. So that's going to be k kids with no cookies. Let's see if this works. Oh, that works. It still seems awfully slow, though. Let's give it a shot. Time limit exceeded. So let's use this test case. That's funny. I thought we did use this test case. All right. Let's swap this around. Let's do this calculation first, so we don't have to go through this max calculation here. Let's do this. All right, one thing I am not doing that maybe I need to do, I don't have this local or non-local cookie count. I don't think that should matter. All right. So I will take my cookie count minus my cookie index. If that is less than, okay, that looks good. Oh, this should have been new kids with no cookies. Yep. Okay, let's submit this, see how we do. Okay, and we pass. We don't do great. We only beat 52% for runtime and 52% for memory, so not great. We could probably go through and clean up some of this stuff. I'm using a lot of these variables that we don't actually need variables for. Like, we could grab this remaining cookie bags. We could just move this whole thing down here. We could get rid of some of these spaces. Anyway, I'm not going to spend too much time on this one. All right, so this is an example of recursion with backtracking. You essentially add the element, do your processing, your recursion, then you pop the element back out. Okay, that is it for me. Hope you enjoyed this. Hope you had fun. Hope you can go out and write better code.